Hello, Leonardo. Hello, Pedro. Hello, Yahel. How are you?
Hi, how are you, David?
I'm fine. Thank you very much. So there was a slight confusion with the time zone, but we were able to all synchronize and be here at the right timing. Yael, I'm glad you mentioned it, because even though the timing didn't change for Israel, it actually changed for the North American, South American countries.
Oh, okay. Okay.
So your email was very helpful.
I just wanted to make sure.
I was able to let Leonardo know that he would start an hour earlier, actually.
Okay.
Yeah, thank you. Yeah. Yes. For me, it's something new because I came from Ecuador. In Ecuador, we don't have these changes of the schedule. Oh. So yeah.
Okay.
Okay, very good. So the idea here is, so we have 3 papers on the agriculture side of our workshop. We actually are missing some people from Norway, which had a paper on, which was a supervised learning solution for row following tasks in horticulture. All these papers are available in the workshop website, as well as the videos of the presentations. Okay, so feel free to watch them later if you haven't had the opportunity. And so I think we'll start with Leonardo. So you have the paper on route planning for multiple hand trailers in manual harvesting operations. My suggestion would be, Leonardo, for you to present yourself first and talk a little bit about the group and the research you're doing, and then we'll do some questions. Okay.
Okay. Okay, so thank you, David, for the presentation. And for people who don't know me, because I already met David in Portugal, I'm Leonardo Guevara, PhD candidate from the Technical University Federico Santa Maria in Chile. I came from Ecuador, but I'm living here in Chile. So right now I'm doing my PhD in agricultural robotics. I mainly focus on the autonomous navigation strategies for vehicles with multiple trailers. So that was the focus of this paper too. I did a research stay in Portugal at the beginning of this year, just before the pandemic situation started. So I was there in the University of Coimbra. So I met David there, and I was working with the supervision of the Professor Rui Rocha. Mm-hmm. So in our article, we basically proposed the introduction of a fleet of autonomous vehicles with multiple trailers to assist the human pickers in the transportation task during the manual picking operations. It's a not fully automated process, it's a semi-automatic process. We consider that the field is divided into harvest areas. Each one will be covered by a group of workers and a single vehicle at a time. But if necessary, other vehicles can use trucks from other areas. In this context, in order to keep the fleet of vehicles coordinated, we propose a decentralized cooperation strategy that computes an initial route plan based on a prior information that we have. But during the harvest operation, the routes can be adjusted and recalculated by the vehicles based on new local information. These methodologies that we presented here in our paper try to optimize the efficiency of the manual harvesting operation by reducing not productive times during transportations, the distance traveled by the machinery when the crop is inside the trailers because it produces damage on the fruits, and mainly the optimize the usage of the machinery itself. So that was the point of this paper. It was just the preliminary results and some snapshots of the simulator that we developed to test several scenarios. And the complete paper was just submitted these days to a journal, so we are under revision.
Don't forget to share the paper. The other one when you can.
Yeah.
It's very interesting. Sorry.
Thank you very much, Leonardo. Yeah, I actually had the opportunity to meet you in Coimbra. So during your research day, we actually had the opportunity also to discuss a bit about your work. I still have I can start with a question I have. I think I already discussed this with you, which is, I know you had this work that was preliminarily done in simulation. And I would like you to discuss a little bit more about if you plan to use a more robust simulation engine if you plan to deploy this on the real world, and what would be the challenges, the big challenges that you would, the major challenges that you would face that you normally do not face in your simulations?
Yeah, the main problem with this kind of like, how to say, implementation is that we have to have permission to do that in the real environments. Here in Chile, we have like a treaty with an institution, which is like the INEA. It means the National Institute of Agricultural Research. Now we allow us to do some experiments in these orchards that we have here. But the problem is, if we need to test this kind of like a fleet of vehicles there, first we have to buy a lot of like vehicles and automate it there. So it will cost a lot of money. And after that, the pickers, the human pickers that will be working there will not be like trained to collaborate with the robots yet. So it will be a really long-term approach. So in this case, we try to propose this road planning approach as a short-term solution, because it could be used not for fully automated vehicles. It could be used like a advisor for the farmers to to follow the optimal routes, how to manage the use of the vehicle, because in this approach we also optimize the number of trailers that we have to use per run, because if a trailer is filled up, if a vehicle is filled up because the trailers are full, it needs a backup to resume the operation. So in this case, this approach also determines the departure times. It has a scheduler to determine the departure times of each backup to avoid this waste of time during the changes of the vehicle. So in this case, this is like the most important contribution, more than implement a real fleet of automated vehicles that is a really long-term like reality. Mm-hmm.
Yes, I totally understand. I can imagine the effort. Working in the field, I mean, agriculture specifically, is hard and challenging and time-consuming. Doing this with a fleet of robots.
Actually, in the INEA, in this institute, they are mostly focused on the perceptions than using robotics for the automation. So they are just using sensors to improve the efficiency in the monitoring or this kind of things, to detect like illness in the fruits, than using automated vehicles to do that. Mm-hmm.
Yeah. Thank you, Leonardo. Yael and Pedro, do you want to ask any questions?
Yes. I mean, not a question, just a comment. First of all, it's great work. I liked also the paper or presentation. I don't remember now if I read it or saw it. I would really focus on, I mean, it's a very nice work because it's kind of a new concept on the integration of robots and manual work together. But you do need the data. So perhaps you can, I mean, I first of all would focus when you present the concept on presenting the logistics management concept. So you're doing it for logistics operations. Maybe you won't get to actual real time on the demand invite of the robot to the best place, but even just doing overall management is a very good advantage in the planning aspect, because we know, for example, just for planning the optimal harvesting time, you want to know what is the best time and how many robots and how many people and so on. And then also, I think, I don't know how, but if you can get some real data, it would be very powerful and important.
Do you mean the data about the harvesting rate of the pickers, the real harvesting rate? Mm-hmm.
Now, I know in Europe, in greenhouse management, I don't think in the fields, but in greenhouse management, they really have, like in any manufacturing system, they have, with RFIDs and everything, really exact information on each picker, which you know, for traceability also perspectives, who picked what into which box and so on. I don't know if that information is available at the field level, and I don't know if it's available outside of I mean, like I know in Israel, we don't collect that amount of information.
Yeah, when I was doing my research about the state of the art, I read a paper from the UC Davis in US, in California, and they were estimating they were trying to model the stochastic behavior of the pickers, locating several RGB cameras in the orchard, not in a greenhouse, in an orchard. So they were estimating the harvesting rate of the pickers in different hours during the morning, afternoon. So they were kind of finding a model of this behavior. So we were basically doing the same with that, like modeling as a stochastic variable, the harvesting rate of these pickers. But yeah, we didn't have the real data to let's say, to train this model.
Just a tip, Leonardo, and because data is a problem for everyone, there's a very interesting group called Rose Agriculture. I'm not sure if you are part of the group or not, but they are trying to look at the data set and make data sets.
How do you spell this
Rose
group?
Agriculture. Let me give you a link for that. Rose.
Yeah, it's mostly for robot operating system users,
Yes.
but it's focused especially on agriculture. So it's the Rose Agriculture Special Interest Group.
Yeah.
Okay.
I'm just trying to find their website so that I can share with you. And I think everyone has a very big problem with that in terms of data sets. Every time that we need a data set, nobody. Okay, I've shared the link. Okay, it's a culture that is growing. Okay, so I'm also, when I have some time, I try to contribute to Rose Agriculture as well. And I think if people keep trying to somehow to contribute to this to make data sets available, it will make much easier, because as you are aware, it's a very big problem every time that you want to train a new model on the data set. It's very challenging, and it's very easy to say, oh, how robust is your solution, how good is your algorithm, but then when you speak about a benchmark, it's really difficult to find one. Yeah. So.
And it's a especially interesting group for discussion of this type of comparing performance in the same data set, comparing, and it's one of the things that drives research. It's exactly this kind of benchmarking.
In fact, David, you are also involved when I start to bring you back. I think it was February or March, where we start to somehow to create a data set. And now you have a couple of data sets there. I know it's still very small, but well, it's better than what we have been doing, which is basically try to find random videos on internet and try to download the video and do the annotations and somehow make it work.
And one of the things I noticed, and Leonardo, I don't know if we are done with your paper, or do you want to add anything else? Otherwise, I will carry on.
Sorry, what did you say?
So Leonardo, can we move on to the next paper, or do you want to comment on anything else regarding?
No, it's okay. Yeah, we can continue. Thank you very much.
So thank you very much, Leonardo. I was doing the bridge for your paper Pedro,
Yes.
as we realized so the experimental part of your strawberry detection algorithm was based on a YouTube video, right?
Yes, that is correct, because we got COVID. We are living in United Kingdom. We don't have, I have strawberries probably in Lincoln, but because we couldn't leave the house, we had to figure out a solution. So this was a master's final year project with my student Samuel Brandenburg. And well, this year was very interesting because of COVID, and we just had to use our imagination to make it work. So we focus more on, first, one of the big problems is to do edge detection. Okay, one thing is to run an algorithm on your computer where you are sitting down and everything is fine. I have here a nice workstation with 20 cores and 64 gigabytes, and I can do that whatever I want. The problem is, as soon as you install a system on a robot, you don't want to, for example, to spend more than 50 to 100 watts, okay? And this is the main reason why we are using FPGA / MPSoC technology, where we take advantage of a common processor to run a standard operating system, in this case Ubuntu, and we use the FPGA to do the acceleration of the algorithm. So in our paper, we don't introduce a new AI algorithm. What we have done was to optimize this algorithm, to train the algorithm to be able to recognize, in this case, strawberries. And we did this using RGBD camera. Okay, in this paper, we didn't explore the depth of the camera, but because the overall goal of the research is to be able to grasp, for example, an object, or in this case a strawberry, you need to get also the depth information. So this is the main reason why we are using RGBD camera. And we are using the Xilinx FPGA boards because you have, as I mentioned, you have a heterogeneous platform where you have half of the devices an ARM processor, A53, equivalent to a Raspberry Pi, and the other half is an FPGA that allows to accelerate the algorithm. The way we are able to accelerate the algorithm is by converting weights from floating point into fixed point. And these allow us to describe the algorithm on the FPGA. We use the IP from Xilinx called the DPU, which is a deep processor unit. And at the end, we were able to get interesting results, especially when compared, for example, with a Raspberry Pi that has the same processor. So, for example, if you attempt to run YOLO on a Raspberry Pi, you're going to get something like 2.66 frames per second. And if you think about a mobile robot going into the farm, that will be a very big challenge, because 2.66 means that the robot has to go very slow if you want to take a decision. And with the implementation that we did, we managed to get 13.05 frames per second. Is still not the best, okay? We have ongoing work. This was preliminary results. We are trying to optimize and by doing pruning. But nevertheless, if you compare the 13.05 frames per second with the 2.66 that you have on the Raspberry Pi, I think is very, very interesting, the outcome. Sam, in this case, had to download the video from internet. He had to annotate and then train the neural network initially on YOLO on darknet, and then convert the weights using the tools that are available on Xilinx into the format that is then used on the FPGA. And what we try to do here is to explain the procedure of what all the steps that you have to go through that. Again, the novelty is not in terms of the AI itself, but in terms of developing a methodology using a bleeding edge technology that has a lot of issues, especially on the Xilinx tools. And I think this was the main outcome, and I'm happy to take any questions that you may have. The paper is available on the conference site, but I'm happy to share with you if you want to just ask me, and I'm happy to share that with you.
Perfect, thank you, Pedro. Anyone has any question to Pedro?
Yeah, I didn't understand at the beginning when you say that why you decided to use YouTube images for this.
Well, because I didn't find a good data set in terms of strawberries, okay? And we couldn't go on the field and get the strawberries. So what we did was to search on the internet videos with strawberries, and this was the main reason why
They couldn't go on the field because of the pandemic.
Yeah, and because we are also in the United Kingdom, okay? You don't find strawberries outside. You have to go to specific farmings, and you need permissions and so on. So all of this work was around April, May, and June. So it was during the crisis.
And it was not a problem when you are mixing images from different sizes. How did you do that? I didn't hear when you explained that.
What we did was we converted the image. We do a resize. Okay, so when we capture the image, we always resize the image into the size that we are going to use. It's not ideal, but allow us to run and to be able to do what we need to do. Yes.
What will be interesting is really once you get to the field, is really to see how the transfer and what is needed for the transfer.
I cannot answer in terms of strawberries, but I'm also collaborating with a company, and we have ongoing projects on the field. And I have to admit, it's working very well. I can share with you offline some videos that we are doing. And that's why I like so much the videos that you find on YouTube, because you don't treat the videos. So somehow you are working with raw image that you are most likely finding in the field. And if you have good annotations, my comment is that your neural network will probably be able to generalize and work on the real, on the field. So that's my main comment on that.
Pedro, so in your paper, you also had access to not only to RGB data, but also depth data, right?
Yes, yes.
So one of the questions would be, do you plan to use this depth data on detection of strawberries?
The answer is probably not in terms of strawberries. I'm not sure about strawberries as strawberries, but I have another student working on what we call the 3D convolutional neural networks, where we are trying to improve the detections. One of the problems when we use, for example, YOLO, is that it tends to be very biased on the color and on the area. Okay, and with depth, you are able to get some more information and reduce that bias. So what we do is we use homography to align the image, RGB and depth, and then we do the annotations in 2D, but then it's very simple to use the same annotations for the 3D because you have the information. This is an ongoing work. Probably if you host a new workshop next year, we are probably going to publish on that for sure. And as we were expecting, is improving the detection. Also, I like to highlight something. The camera that we are using is the Intel RealSense D435, and the camera comes with near infrared. One thing that I came across is that, for example, when it's dim, when you have dim light, for example, at the end of the day, you don't have any image already on the RGB, and the near infrared is still picking up the information. And this is very interesting because the same happens when you have very intensive light. We are now measuring the light, monitoring the light intensity, and we are trying with different lights, and also with dim light as well. And it suggests that the detection is being improved because of that. So, for example, if for some reason you have to work at night, and this is one of the challenge for the new agriculture. Of course, you can have a light and shining, but if you have a robot on the field, and if you are using if you have to turn on a light after a few hours, you may be decreasing the life of your battery. But if you have cameras that are already near infrared and you have enough information to detect what you want, you should be able to keep doing what you are expected to do just with the lights, with something like a near infrared that is already available on the camera. And this is my comment. It's also a hypothesis.
Another idea which you might use, which helped a lot. I'm not sure if the strawberries are outdoor or in kind of tunnels.
Outdoor.
Yeah. Okay, so I'll send you the paper.
Yes,
pick it up and send you. But we did something with flash, no flash. So you put a light, and then you take one without, and it really improves the results. It's amazing to see how it improves the results.
Oh, thank you for that.
Because it kind of disturbs the external light, which is always as it's natural, changing all the time.
Yes, that's very interesting. Have you done any work regarding, for example, trying to capture the NDVI during nighttime? Do you know what the NDVI, where you take the near infrared and the red? Have you tried to do that as well?
Yeah, at night. First of all, at nighttime you get better results. The question is, do you want to limit yourself only to nighttime? That's kind of a trade-off.
Yes, I see what you mean.
Because you can better control. So at night the results are much better.
Mm-hmm.
But what you mentioned here, I would try, since cameras now are much more sensitive, it might be worthwhile to try and go really to the spectrum, or even special filter design. I mean, in order to get, and again, it depends also on the fruit, but for strawberries, definitely, the infrared could be very easier detected.
That's
but I'll send you, but night for sure is easier. The question is, do you really want to limit yourself?
No, limit never. Just thinking about what we can do and how close are we for TRL9. As I said, I also work with the company and we are always looking for partnerships. So if you have some ideas, and I like the suggestions that you're giving.
I'll send you some of this stuff.
Yes, thank you. So,
Pedro, I have one last question.
Yes.
So how far are we, do you think, to getting to a point where using these FPGA solutions instead of GPUs in the field would become feasible and widespread?
From our perspective, and now I'm going to speak from the company perspective, I would say that we are, in terms of the company, we are probably 6 months to 1 year to have the first commercial product. We have been actively submitting proposals for cascade funding, and the main goal here is to push into a TRL9. I can tell you that over the last 2 months, we submitted around 8 proposals for cascade funding. So, and as you are aware, cascade funding, you normally have 6 months and you really have to make it work, otherwise you don't get the funding and you don't get the money. So I would say in terms of company, I think we are around 6 months to 1 year, especially spraying, because it's one of the things that we have been doing, using the image to control the nozzles. And we have been working a lot in that sense, and we have the first results. For example, the solution that I'm talking about, we are using, using the image to compute different angular speeds. So for example, when you have a tractor and if it's spraying and when it's turning, you'll notice that the angular speed, the inner angular speed, it has to be faster, while the outer is going to be slower. And we have been looking into that. We have been integrating this on the FPGAs. I can say that we are not speaking here about accuracies of 95, 98%, but I can say that we have a functional solution working with both the FPGAs technology and also the cameras, which is very challenging.
I'm really looking forward to it.
Yes, absolutely.
I'll order you one when you have that ready.
If it was 1 year ago, I would say, oh, we are far away. But knowing what's happening now,
getting closer, right?
Yes, we are getting closer and closer. Especially because the Xilinx tools are now much more mature. We had a lot of issues because they released a new framework last year. It was completely new and full of bugs. You could not follow the tutorials and so on. And now all of that is sorted.
Okay, perfect. So we have a third paper from the Norwegian research group, but unfortunately they are not present here. I think we have a guest, which is Hiroki. I don't know if Hiroki wants to add something to the discussion. Hiroki, feel free to unmute your microphone and discuss with us. And so my suggestion would be, if we are done with this session, since we don't have the third paper, we would join the other session and wait for them to finish, and then we'll go back to the main room. Is it okay?
Sure. Yeah, please.
So I will send everybody to the other session, okay?
Yes.
Okay.
Before you go, I just want to leave my email if you guys want to drop an email. Okay, because we are here to do
in the paper, I think.
Yeah, it's on the paper, but I like to. This is more personal. I see .uk. And I think we should use all the opportunities for us to look into partnership and networking, especially now that we cannot leave the house almost. So I'm leaving my email. If you guys want to share your email as well, I will definitely send you an email on a follow-up email.
And before leaving, let me say also that we all look forward to Yael on the keynote speaker session.
Yes.
Okay? So we have a video presentation from Yael on the Iris On Demand platform, and she will be speaking a little bit more about the lessons learned in the Crops EU project, where she was the main coordinator of the project. So we're also looking forward to that. Okay, so in a couple of minutes we'll get to that.
Okay.
So Hiroki says my mic was broken. I will ask you by email. Okay, Hiroki.
Okay.
Thank you very much. So let's all join the other session.
Okay.
See you soon.